Hi, I'm Krishna. This is day 6 of 30 days of understanding the modern AI stack. So, in this video, we're talking about the weight initialization. The thing that nobody respects until their model collapses like a Jenga tower. Every beginner goes through this. You build a model, hit train, and it learns absolutely nothing. Loss, flat, gradients, dead, and your hope also dead. And you start doubting your life choices. But here's the plot twist the model never did anything wrong. It was already guaranteed to fail before the first epoch because the weights were initialized in the worst possible way. So, why initialization matters? Think of every weight as a knob. The optimizer turns these knobs to reduce loss. But if the knobs start too tiny, gradients vanish. Too large, gradients explode. Identical, every neuron learns the same thing. Random network becomes a philosophical mess. Initialization decides if learning is possible, stable, smooth, and not a mathematical horror movie. So here's the intuition. When data flows through a deep network, it's multiplied layer after layer. Activations multiply, weights multiply, gradients multiply. If weights are poorly chosen, this repeated multiplication either shrinks everything into nothing or amplifies everything into chaos. Initialization job is to keep the signal balanced forward and backward. It's like giving your network insulin, too much or too little, and everything spirals. So let us discuss two ways of proper initialization. First one is Xavier initialization by Glorot. Use it when activations are 10H, sigmoid, and linear. The goal is to maintain a variance so signals don't shrink or explode. Second one, He initialization by Kaiming. Use it when activations are ReLU, leaky ReLU, GELU, GELU. Goal is to compensate because ReLU kills half the output. And if you are planning to use ReLU without He initialization, bro, good luck. That's like trying heavy squats without a warm up. You might survive, but your model's knees are gone. And before 2010, training deep networks was like convincing your crush you're a nice guy. You kept trying, but nothing worked. Then Xavier and He initialization showed up like, bro, your starting point is wrong. And suddenly, deep learning took off. And yeah, these modern models are no exception. You need to have proper initialization so that your model actually learns. So, which one should you use? It all depends on your use case. If you are using ReLU, SILU, GELU, go with He initialization. If Tanh and Sigmoid, go with Xavier. And we use orthogonal and initialization for RNNs. It all comes down to your use case. You don't need 10 options, you need correctness. Good initialization is like tuning a guitar before you play. If the first note is wrong, the whole song is wrong. So here are some quick visual demos. Here's a training with bad initialization, dead flat loss. And here's a training with Xavier, stable. And here's a training with He, fast learning. It's wild how something that happens before the first forward pass determines everything. So that's weight initialization, the silent foundation of machine learning. For more resources, check out the description. In the next video, we'll go into CNN fundamentals. So see you then in the next video. Let's do it.